Chapter 8 is going to be all about hypothesis testing. So hypothesis testing can be a difficult topic. So before we dive right into actually doing some hypothesis testing, in section 8.2, we're going to talk about the basics of it that you use whether you're testing a proportion or a mean, as we'll find out. So here's something that makes sense, but we should just state. So it's called the rare event rule for inferential statistics. So if, under a given assumption, the probability of a particular event is extremely small, we conclude that the assumption is probably not correct. So if you make some assumption and then something happens that would be extremely rare to happen, your assumption was probably wrong. Now, the very first step of hypothesis testing is setting up what are known as our null and our alternate hypothesis. So our null hypothesis, we have an H and we put a little 0 by it. And our alternate hypothesis, we put H with a little 1. So the null hypothesis, denoted H0, is a statement about the value of a population parameter, and it's always equal to some value. So when we have the statement for our null hypothesis, it's always going to have an equal sign in it. The alternate hypothesis, which we call H1, is a statement that has a value that differs from the null hypothesis. And it's always going to use a greater than symbol, a less than symbol, or a does not equal symbol. Now, so here's what happens. Our claim is either going to say something's less than something, greater than something, or equal to something. If it says it's less than or equal to something, that claim will be our alternate hypothesis. And then our null hypothesis will be equal. If the claim says something is equal to something, that claim will be the null hypothesis. And then in that one case, when the claim has an equal sign, we'll use a does not equals for the alternate hypothesis. Okay, so we're going to go through several examples here. So this says the claim is that less than 50% of all adults say that cloning of humans should be allowed. Okay, now this is a proportion, so we'll use the letter P. And it's a less than. So our alternate is going to be P is less than 0.5. Okay, the proportion of adults is less than 50%. And then our null is always P is equal to 0.5. We use an equals. Okay, so since the claim had a less than, we make that the alternate. And then we use that same statement, but with an equals for our null hypothesis. Okay, number 2, the claim says the mean head circumference of all 2-month-old babies is, so is means equals, 40 centimeters. Now, since our claim is an equals, the equals always goes in the null hypothesis. So we'd say the mean, mu, is 40 centimeters. And when we've used our claim as our null hypothesis, then the alternate hypothesis is always does not equals the same number. Okay, so if we look at number 3, the claim is that 30% of all federal arrests are drug-related. So again, this is an equal statement. So our proportion, we're saying our proportion, so it's a percentage, is 30%. And again, since that was our null hypothesis, and that was our claim, we'd use a does not equals for our alternate. Number 4 says the claim is that the mean internal body temperature of healthy adults is less than 98.6. So since this is a less than statement, we put the less than statement. So an average is less than 98.6 as our alternate hypothesis. And our null hypothesis always has to have an equals. So we'd say mu is equal to 98.6. Number 5 says, among smokers who try to quit using a nicotine patch, over half of them are smoking again 1 year after treatment. So over half means more than half, greater than half. So here we're talking about a proportion, 50%. And so we'd say our proportion is greater than 0.5 or greater than 50%. And our null is always the equal, so P is equal to 0.5. And our last one, the claim says the mean weight of all adult black bears is more than 200 pounds. So since this is a more than, that's our alternate statement. The mean weight is more than 200 pounds. And then we make our null hypothesis the equals. Okay, so that's setting up our null and our alternate hypothesis, which is always your first step. Okay, and you might want to put a note next to it of which one the actual claim is. So here the claim was the greater than, so we might just put claim, so we remember at the end which one we were wanting to know about. Okay? Now, no matter what your claim is, for testing purposes, we always assume that the null hypothesis is true. Okay, and so after the test, the first thing we always do, our null hypothesis is either rejected or not rejected. So those are the only two possibilities, kind of at the end of the test, that the null hypothesis is either rejected or not rejected. Now, if the null hypothesis is your original claim, you'll kind of stop there. You'll either say you reject it or you do not reject it. If your original claim was the alternate, like we saw in number 6, then depending on what you do with H0, we'll have rules about what you do with it. And the only two things you can either do, you can either support it or not support. Okay, so you do have to be very careful about what your original claim is, and then which one what you can say about it. So the first step, which we practiced in numbers 1 through 6, is to write the null and the alternate hypothesis, and to make a note about which one the original claim was. Now, just like when we had confidence intervals, we're going to have a significance level here. Okay, and it depends on how serious you want it to be. Okay, so we'll talk about either having a 1% error, a 5% error, or a 10% error. Okay, then we'll use a calculator to find what's called a p-value, and this is the probability of this actually happening. And depending on what type of hypothesis test we're using, we'll talk about how the calculator can find that p-value for you. So then here's how we know what to do. If the p-value is less than alpha, less than your error, okay, then we reject H0. And if it's greater than alpha, we do not reject H0. Okay, so remember, we're always testing our null hypothesis. So once we've tested that, okay, then we can make our final statement. Once we've decided, do we reject H0 or do not reject H0? If our original claim was the null hypothesis, if it was rejected, we would say something like, we reject our claim. If it was not rejected, we would say, we do not reject our claim. Now, most of the time, your original claim is actually going to be your alternate hypothesis. If it's your alternate hypothesis and you rejected H0, then you would support your claim. So you rejected the other one, you support your claim. Okay, and if you did not reject your null hypothesis, then you do not support the claim. So it is a little tricky to get all this wording down. There's a great flow diagram in the chart that comes with your book. But it does take a lot of practice and careful thought about what your original claim was and then what you did with the null hypothesis.